Hi, my name is Mark Schwartz and I'm the Managing Director of iTech Minerals. And today I'd like to present our 2024 AGM presentation. Now, I've recorded this online so that if you can't attend the AGM in person, that everybody gets a chance to see me present the presentation that's given at the physical AGM. So let's get into it. I'd like to present the board. We have Glenn Davis, who's our non-executive chairman, myself, who's the managing director, Gary Ferris, also a non-executive director, and Yarrick Copius, who's our chief financial officer and company secretary. So today the presentation is going to be broken up into three different parts. I'm going to talk about our lithium projects in the Reynolds Range first, then our copper gold projects at Reynolds Range, and then our graphite projects on the Eyre Peninsula in South Australia. So what I wanted to point out was that all these commodities that we're looking at are all being used in the critical mineral sector, and in particular in producing lithium-ion batteries and the electrification of the economy that's going on around the world, and the revolution that we're having in converting to electrical energy. So at the beginning of this year, we picked up the Reynolds Range project in the Northern Territory, and that consisted of 3 licenses. It covers about 375 square kilometres in the Aileron province, which is about 140 kilometres north of Alice Springs. Since that time, we've also applied for a new application to the south of those tenements, and that increases it from 375 square kilometres to over 792 square kilometres, so nearly double the size of the ground that we're holding at the Reynolds Range project. And we took those tenements up to complement our existing tenure on the Eyre Peninsula, where we're exploring for graphite for battery anode material, and expanding out into the lithium and copper gold aspects of the critical minerals portfolio. So diving into the lithium potential of the Reynolds Range project, we're very pleased to have made a new lithium pegmatite discovery at Reynolds Range this year. So we went out there and we looked at some of the existing tin workings that we knew existed on that tenement package, and we're very pleased at the second location we went to find very large spodumene crystals that are being dug up out of some of the old tin prospecting pits. And some of those rock chips returned well over 8% lithium, which is near the theoretical limit of pure spodumene. So we were picking up very large monomineralic or pure spodumene crystals at surface, and that's what we put in for assay. So we went and we did some rock chipping across the GMF pegmatite, and what we found was that we have a thickness of that pegmatite roughly in the order of about 80 to 90 metres, and we got nice rock chips across that whole intersection, from anywhere from 6.5 up to 8.2% lithium oxide. So very high grade rock chips, because we were picking up these very coarse spodumene crystals. That pegmatite in particular, we can see outcrops about 290 metres from north to south and then disappears undercover. So we're not sure what the true strike extent of that pegmatite is, but we will have to go out there and do some drilling to determine exactly the true thicknesses and strike extent of that pegmatite. But what we do see at surface there is we've got very coarse spodumene crystals that's associated with quartz, albite, plagioclase, muscovite, and tourmaline. And then when you get to the margins of that pegmatite, you get tourmalinite being crystallized, which is a very tourmaline-rich rock type within a schist that hosts the pegmatite there. So yeah, it's early days yet for the GMF1 pegmatite, but from what we can see, there's quite abundant spodumene at that location. And we've confirmed that it is spodumene. We took those samples, and not only did we get them assessed for the lithium content, but we also had XRD done on it. Now, XRD is a way where you can shoot it with X-rays and you get a spectra back, or a wavelength of the crystal, and you can, from that wavelength or that spectra, you can then determine what the mineralogy is, and that's come back with being over 80% spodumene. So we've confirmed that the lithium bearing mineral is spodumene, which is the one you want within pegmatites for it to be the most economic and easily processed. So when we're looking at the surface of the GMF pegmatite, we can see that the spodumene is extremely coarse. It's up to, some of these crystals are up to 40 centimetres wide and nearing on a metre long, as you can see in this slide here. And interestingly, the spodumene comes very close to surface. It does get weathered, but it comes to at least within 30 centimetres of the surface. So that means that it should make our soil geochemistry and exploration in the area quite effective in identifying new pegmatites that are spodumene bearing. So yeah, it's a good win. The other thing that's very important at this location is that the host rocks for the spodumene bearing pegmatites are schists, and they have quite low density. So what that bodes well for, with it being coarse spodumene and a low density host, is that dense media separation should be a suitable metallurgical process to be able to produce a spodumene concentrate. So if you have host rocks that are very close to the density of spodumene, it's very hard to separate them with gravity. But in this case, we haven't. They're quite distinct. The schist has a density of about 1.6 as opposed to over 3 for spodumene. So there's a good contrast there for dense media separation. So extending the lithium potential beyond that GMF pegmatite, we've had a look at a couple of pegmatites nearby, both the Mount Stafford pegmatite, which is about 3.5 kilometres away, and then the GMF 2 pegmatite, which is about another 1.5 to 2 kilometres away. And we're getting very good indications that those two pegmatites should be spodumene bearing as well. So if we look at the GMF 2 pegmatite, which is about 1.7 kilometres to the west of the GMF pegmatite, there we can see large swarms of pegmatites. So there's at least 5 or 6 pegmatites that we can see in a stacked array that have intruded a fold hinge over quite a distance at that location. The mineralogy is that we can see quartz, feldspar, tourmaline, muscovite, and beryl in those pegmatites, and we can also, what we believe, are remnant casts of spodumene. So we believe that there was spodumene present at the surface there, but it has now been weathered away. And that is really reinforced by the fact that when we test the potassium feldspars at that location, the rubidium contents are quite high. And that gives us an indication of how fractionated and likely to crystallise spodumene these pegmatites are. So we've got about 5,000 ppm rubidium in the potassium feldspars, which means that we should be getting spodumene dropping out at the GMF2 pegmatite as well. So then if we jump up about another 3.5 kilometres to the northwest at Mount Stafford, another pegmatite occurs there, which is outcrops over about 750 metres and looks to be anywhere from 20 to 40 metres thick. The rubidium in the potassium feldspars there is going up to 6,000 ppm. So again, another highly fractionated pegmatite, within this vicinity of known spodumene-bearing pegmatites at GMF. So, including Mount Stafford, GMF2 and GMF1, we've got about 5 kilometres of outcropping pegmatites that are highly fractionated just in this one location where we first started looking. So, from there, we've got about another 60 kilometres of outcropping pegmatites across the whole Reynolds Range lithium project. So let's talk about the regional lithium potential at Reynolds Range. So we've done a desktop study and tried to identify how many outcropping pegmatites there are from the satellite imagery. And to date, we've interpreted about 120 outcropping pegmatites from the satellite imagery across that full 60-kilometre strike length. Now, we've only just started being able to get on the ground and have a look on the ground at some of the broader regional potential. But what we're seeing is that we're getting anywhere between a 60% strike rate when we go out and we check what we've identified in the satellite imagery. About 60% of the time, those actually are pegmatites on the ground. So we're getting a pretty good conversion rate from what we've interpreted to what's on the ground. So, and what we're seeing regionally is some of these pegmatites are really quite large. We've mapped some that are up to 1.2 kilometres long and well over 100 metres wide, as you can see, a drone shot of one of those pegmatites on the slide at the moment. So we have some exciting news we've just announced in the late last week was that we've now done a deal with one of the world's largest lithium chemical producers, SQM, on the Reynolds Range lithium project. So I'll give you some details of that project. We're very excited by this deal. We believe that being such a large, potentially new lithium province to explore, that we need the financial and technical resources of a major company within this space to help us quickly identify the best areas to drill and then to explore and drill out those occurrences. So I'll give you some details of the deal that we've done with SQM. They after having done a very short due diligence period, they will pay us $2 million in cash on top of the $4 million we have in the bank to acquire 30% interest in just the lithium rights on the project. So ITM or iTech will retain the rights to all other minerals. So copper, gold, silver, all those we retain 100% of the rights to, and we also retain the ownership of the tenement. So SQM are just earning into the lithium rights, and they will pay $2 million to get a 30% initial interest. Then they have the option to earn up to 51% of the lithium rights by spending a further $7 million on exploration within 4.5 years from the commencement date. And they have to spend a minimum of $2 million within the first 1.5 years. So they need to get out there, get on the ground, and start drilling and exploring quickly under this agreement. Then once they've acquired that 51%, they then elect to go and earn another the next stage to earn 70%. They have to pay us another $3 million in cash to advance to that next stage. And then before they earn 70%, they either have to drill out a JORC compliant mineral resource estimate exceeding 50 million tonnes at an equivalent 1% lithium oxide, or if they spend another $15 million on exploration, they will achieve that 70% earning. So having done that, we will have 70% of the lithium rights owned by SQM and 30% owned by iTech. So then there's the further option for the payment of a one-off success fee, and that's payable by SQM to iTech upon completion of a definitive feasibility study and then a positive decision to mine. And that fee will be calculated essentially on the amount of lithium oxide content that is in the resource. So so ITM has the potential to earn another significant cash payment at that period. So during the whole earning period, SQM will be operating the project. They'll be doing the exploration on the ground, which allows iTech to get on with its copper and gold exploration. So we debated long and hard internally about whether we should go it alone and drill these projects ourselves, or whether we should bring in a major partner on the project. And what it came down to, we believe that the lithium markets at the moment have a very volatile, and it is not easy to be able to go and raise capital in this market. What you really need to do is to be able to drill a world-class drilling intersection before the market takes notice. Now, we believe that possibility exists at Reynolds Range, but the continuity and the certainty of ongoing funding and technical capability to explore the tenement package is not really a given in this volatile lithium market. So by having SQM in there, they have the technical and financial capacity to see this program out and to define that 50 million tonne resource to get to 70%. So we believe it is the least risky and the most sure way to get to that point and really create value for iTech shareholders, having achieved that milestone. So then that leaves iTech with the 30% of the lithium rights at the end of that, but then 100% of the copper, gold and base metal potential at Reynolds Range. So let's talk about that. So this year we've made great inroads in understanding the copper and gold potential at Reynolds Range. We've done a historical review and really believe that there is exceptional both gold, copper and base metal potential that has been previously drilled mainly for gold in the past, but there are some very exciting walk-up drill targets, particularly at Scimitar, for copper, gold and base metals. So over the past few months, we've been doing an extensive mapping campaign and taking a lot of rock chips, really to get an understanding of the mineralisation styles that we need to apply and the vectors and the type of elements that we need to be testing for to understand both the gold only and the copper gold base metal style systems at Reynolds Range. So we've now largely covered that whole 60-kilometre trend, and we believe we now understand the mineralisation styles and the best vectors towards mineralisation over that whole system. So yeah, we've had some pretty nice gold rock chip results over the existing prospects, up to 182 grams per tonne. And then we've discovered a few new prospects as well, such as Cutlass, where we've got a 15 gram per tonne rock chip, and then gone back down to Pine Hill, where we've got a 55 gram per tonne rock chip as well. So we believe, there's quite extensive gold potential at Reynolds Range, both in its own right and then also within some of the prospects like Scimitar and at Reward as well, which have both copper and base metals associated with them. So yeah, we're in the process of defining drill targets. We're getting those drill targets drill ready, particularly at Scimitar, and then doing some more on-ground work at Reward and some of the others to get those projects drill ready. So some of the rock chips we've got around Scimitar and Reward have got well over 15% copper, up to between 3 and 12 grams per tonne gold, and in the thousands of grams per tonne silver. So these are really quite rich systems, as we've proven from the rock chips. What we're seeing, particularly at Scimitar and at Reward, is what we believe is a VHMS style of mineralisation. We've done some work on the geophysics, and what we can see is that there's this magnetic complex which extends for about 26 kilometres, and just adjacent to that, we're getting a lot of this VMS style mineralisation at surface, both at Scimitar and at Reward. So with what we've looked for then is with VMS mineralised systems, quite often they're conductive because they're massive sulfide, so they have a conductive response. So we've looked at Scimitar, and sure enough, there's a nice airborne EM anomaly both there and then also at Reward as well. So we've started focusing on those two prospects as near-term drill targets, but focusing in on Scimitar initially, as that has the largest EM signature. So here's an image of the airborne electromagnetics, both at Scimitar and Reward, and you can see quite a nice response in the red there, where we have mineralisation at surface in rock chips. So focusing in on Scimitar, that also has a very nice surface soil lag geochemistry response, and the copper in soils you can see here extends for over 5 by 4 kilometres, so a very nice copper anomaly in the soils at Scimitar. And then if we have a look on the top left there, you can see the airborne EM response, which goes for about 1.6 kilometres. And then we have a multi-element soil geochem anomaly. So we have copper, gold, arsenic, silver, lead, zinc, and antimony, all very anomalous in the lag soils at Scimitar. And that is all directly over a ground-based moving loop EM anomaly, which extends for about 1.6 kilometres. So that obviously becomes a very compelling drill target. And these are the kind of rock chips we're getting at surface within the vicinity of that. As you can see from the green and blue minerals within those rocks, there's quite a bit of copper being carried around in that surface mineralisation. So we've modelled up the EM because that's going to give us subsurface mapping of where the massive sulfides are most likely to occur, if that's what's causing the mineralisation style here at Scimitar. And there was one drill hole that was drilled by Prodigy back in 2000, and they drilled the very southern part of that EM response, but the lowest part of it, and they got some interesting conductive material with anomalous copper and silver, lead, zinc in that interval, but they didn't test the main part of the target. They got rained out before they could drill the highest response. And we've modelled that plate as being about 2,600 units. So it's about 5 to 6 times as conductive as the area that Prodigy drilled. So our aim is to drill a couple of holes into that target as soon as we can get access to the ground, which will probably likely be early next year now. So we've now established a commanding ground position over the Reynolds Range area. Not only have we acquired the 3 prospects from Prodigy Gold, but we've also applied for a new tenement, which has doubled our exposure within the area. And the reason we applied for that new tenure is that we believe that not only does the new lithium prospectivity extend onto that new application, but also the copper, gold, and base metal prospectivity. So as soon as we knew that that ground was open and we started getting good results from being out in the field, we applied for that application and was able to double our ground holding within the area. So now jumping away from Reynolds Range into the graphite story down on the Eyre Peninsula in South Australia, moving from Northern Territory down to South Australia, and moving to the negative component of the battery, where lithium is the positive component, graphite is used in the negative terminal of the battery. So we've been consistently developing our graphite resource down at the Eyre Peninsula, and we believe that this is still a very valuable project for iTech Minerals. It's 100% owned by iTech, and we believe it's a de-risked opportunity to supply spherical graphite into the battery market. So in the last year, we've increased our resources by over 300% to 35.2 million tonnes at 6% total graphitic carbon. Over one of the deposits, we have a granted mining lease and 2 multi-purpose leases for processing and water infrastructure. So we have the ability to advance these projects to development very quickly if the market support it. We've demonstrated at Campuna that we can process our material by simple flotation into a 94% concentrate and then convert that into a 99.99% pure spherical graphite, which has all the right characteristics for battery anode material. So we've proven that it has all the right characteristics. And then we've shown that we've got the potential to increase our graphite resources on the Eyre Peninsula. So at Sugarloaf in particular, we've defined an exploration target of between 158 and 264 million tonnes at between 7 to 12% graphite at Sugarloaf. So very exciting times for our graphite at the Eyre Peninsula. So if we're looking back at the graphite, so pre-2024, we had a resource of 8.5 million tonnes at 9%. Mine life, if we had a concentrator producing 50,000 tonnes per annum of concentrate, that would give us a mine life of about 10 years. And in the last year, we've increased that to a new global resource of 35.2 million tonnes at 6%, which would then increase that mine life up to a 30-year mine life. So the reason we did that was that to get interest from offtake partners, we need to show that we have a longer term mine life. Offtake partners aren't interested in going through the rigorous testing procedures of your material if you can only supply for 10 years. They want to know that you can produce a high quality product consistently for a long time. So we now have that 30-year mine life, we believe, at the Eyre Peninsula Graphite Project. And we also had the potential to expand that with our Sugarloaf project. So we've been working in the background to produce a number of products from our Eyre Peninsula Graphite. We've shown that we can produce a high-grade battery anode material product, which we're calling iPhite. So that is simple flotation of our ore material to produce a 94% concentrate, and then we've shown that we can purify that to at least 99.9% and spheronize it to produce a nice industry standard battery anode material. So that then goes from the concentrate, which we're calling the iPhite material, and the 94% concentrate, to our battery anode material, which is the spherical graphite, which we're calling our iNode material. And then we've been working on, in the background, our other potential applications for our graphite material, which is iPhene, producing graphene from it, which has been shown that it can be done from the Campuna material. And then looking at that in additives such as iCoat for paints and in concrete. So iCoat for improving the strength of the flexural and improving the flexural and compressive strength of the concrete. So what have we done at Lacroma? Lacroma is proving to be a very geologically nice deposit. It has mineralization from surface. It's got a shallow dip to the east, and to us that implies a low strip ratio and early delivery of product to the market, and hopefully low mining costs, because we don't have to remove a lot of overburden to get to the pay dirt. The graphite mineralization is highly weathered and it's dominantly clay hosted, so we believe a large amount of that deposit has the potential to be free dig, and that then adds also to the low mining costs. The groundwater table's over 60 to 80 metres deep, so we're not going to have problems with dealing with difficult groundwater conditions when we're mining the top parts of that deposit. So that alleviates the issues of acid mine drainage and sulfide affecting the flotation properties of the graphite. So this is all very favourable for iTech establishing a low-cost green graphite mining operation at Lacroma. And hopefully we have the ability to use the abundant renewable energy that is available in South Australia to do that. So it comes down to simple geology and simple metallurgy at Lacroma. It's traditional, the traditional flotation metallurgy, it works. Now that's not true for a lot of other graphite deposits around the world. Not all of them can use that simple flow sheet to produce a 94% graphite concentrate, but at Lacroma we can, and we can do it with very high recoveries of about 95%. So then what's the path to resource growth? So our plan initially was to bring new resources to Lacroma because we knew the metallurgy worked and it worked well. Now we've done that. We've ticked all those boxes. So the next test for us is to where we can significantly add resources to this project. So, and we believe that Sugarloaf has that potential, but Sugarloaf has shown that it doesn't lend itself to the simple metallurgical flotation processes because it's a very fine graphite. Now that has advantages in that you don't have to grind it afterwards to produce the fine graphite you need for battery anode material, but it does make it more difficult to float. So we have a $1.1 million government grant, a CRCP project, that we're working with Mets Engineering and the University of South Australia in order to crack that fine flotation problem. And we're making really good advances on that project. So hopefully we can give some updates to market in the next 6 months as those updates and advances become more material. So at Sugarloaf, we have the potential for a very, very large resource. We haven't drilled it out yet because we haven't yet cracked the metallurgical code, but we're getting close to doing that. So we started out with knowing that there was about 2 kilometres of strike of quite high-grade graphite mineralisation. In the last 18 months, we've been able to more than double that strike length and get some pretty nice drill results. So in the southern part of the Sugarloaf exploration target area, we've got intersections like 28 metres at 15% and 18 metres at 11. Some of the nicer intersections are like in hole 11, we've got 48 metres at 7.2% from just 5 metres, so very close to surface. And then we've got another 49 metres at 16% from about 68 metres. So that's nearly a combined interval of over 100 metres of graphite mineralisation almost from surface. And there's some other really high-grade intersections in there as well, some of them up to 26%. Like in hole 17, we've got 13 metres at 26%. So Sugarloaf has a large strike of high-grade graphite pretty much from surface. So once we crack that metallurgical code at Sugarloaf, we will then have the confidence to go out and drill a resource at Sugarloaf. But we won't do that until we know that we can process it into battery anode material. So then what other targets do we have for graphite? Well, we have the next best one we've got after Sugarloaf is what we call Balumbar North and Balumbar. Now, the reason we like this is it's a very high AEM anomaly. And there's also known drill holes in there, historical drill holes, 3 of them, that have already intersected graphite. So we're currently looking at those as future drill targets for adding further resources to our graphite inventory on the Eyre Peninsula. So iTech's graphite story is advancing. We're looking at expanding our resources at Sugarloaf, subject to cracking the metallurgical code. We believe with the resources we have at Campuna and at Lacroma that we've got all the hallmarks of a low-cost operation. We have excellent ore body geometry with mineralisation from surface. It's deeply weathered with a low sulfide content, has deep groundwater, which mean low mining and processing costs. We know that we can process this material into high-quality battery anode material that is suitable for lithium-ion batteries. So we have demonstrated that flow sheet at Campuna, and we're in the process of demonstrating that at Lacroma. We're located in South Australia, which is a tier 1 mining jurisdiction. We've got abundant renewable energy available, and we have a granted mining lease. So we have the potential to exceed ESG requirements of even the most discerning offtake partners. We're situated to supply into the ex-China market with premium pricing, but also supply the European and North American markets as well. So we've got a market capitalisation which is a fraction of our industry peers, not only based on our graphite projects, but also our lithium project and copper, gold and base metals at Reynolds Range as well. So look, that's a quite extensive recap of all of our projects, but we've been very busy this year across the Northern Territory and South Australia. Hopefully that gives you a good summary of what we've been up to, and thanks for listening. As always, please make sure you subscribe to our email list and our YouTube channel so that you never miss an update in the future.